We're going to work on some parabola problems where we start out given the information. Matter of fact, let me just show you the first problem we're going to work. Let me share my screen. I want to do this in my math lab so you can see how to plot. So you can see this problem. Find the equation of the parabola described below. So they want us to find the equation, find the 2 points that define the lattice rectum, and graph the equation. And here's information that we're given. So I'm going to write down on a piece of paper. They say the focus is at -6, 0, and the vertex is at 0, 0. So I'm going to figure out the equation and the lattice rectum and the graph, and then we'll come back to this page and enter the answers. I especially want you to see how to create the graph online so that you don't get confused. So let's go ahead and go back here and let's work out all that information. So this is one where you're given information and you're asked to find the equation and to graph the parabola. For these kinds of problems, the first thing you always do is you go ahead and you start making a graph with the information you're given. So if the focus is at -6, 0, there's the focus. The vertex is at 0, 0. Now at this point, I know what kind of parabola it's going to be. This is going to open to the left because the focus is always inside the parabola. And here's the vertex. So I go to my formula sheet and I want to grab the standard equation that is for a left or right parabola. In this case, it's going to be a left parabola. And that's this equation here where the y gets squared. So the standard equation for this parabola is going to be y minus k quantity squared equals 4p x minus h. Now hk is a point, which is the vertex. So since we're given the vertex, we know h is 0 and k is 0. So if I plug those in to my standard equation, that leaves us with, there's no more parentheses. Now I just need to find the value of p, and I will have the equation. Well, p is simply the distance between the focus and the vertex. So you can see here, since this point here is -6, this distance is 6, so p is going to equal 6. So now I plug in 6, I get 24x. But here's the last step. Please don't forget. Now you have to check and make sure that this should be a positive or negative. Since this parabola is going to open up to the left, we know it's going to be a negative. So this is going to be the equation of the parabola. Now they ask for the lattice rectum points. Those are the points. In this case, I'm going to move up and down from the focus. And what you do is the lattice rectum, or what I call the spread is how far up you move and how far down you move. The spread I like to call 2p. So in this case, it's going to be 12. So it seems a little crazy, but from here, I've got to move up 12 and down 12. I'll just make an estimate. So I'm going to say this distance is 12, and so this point right here would be -6, 12, And this point would be -6 minus 12. And then with the latest rectum, we can sort of graph this parabola. For the actual points, for the latest rectum, I'll just call it LR, would be -6, 12, and -6, -12. So I'm going to go enter these answers now back in the computer program, and then we will create the plot. So let's go back. So now I'm saying the equation was y squared equals -24x. So y squared equals -24x. And of course, you have to click check your answer to go to the next problem. That's good. Now the 2 points lattice rectum, type ordered pairs, use comma to separate them. So we found -6, 12. Now I need to put a comma in here, and then the second point, -6, -12. We'll check that answer. That's good. Now it's going to ask me to plot this. So what I'm going to do is I'm going to click here. It says to enlarge the graph. So you notice here, first thing you have to do is you have to choose up here to the right what kind of graph you're creating. We are doing a parabola, and you notice this is the parabola choice. And for either left or right, you have to choose this one. So since we have a left parabola, I'm going to choose this. And now what you do is the first point you enter should be your vertex. And then the second is going to be any point on the parabola. I'm going to go ahead and plot the vertex and then choose one of my latest rectum points. So the vertex, and you can look up here at the top, because this is pretty small. I know I want to go to 0, 0, so I can look at the top and make sure I'm at 0, 0, and then I left click. And now I want to go to -6, 12. So I can go here, but once I think I get there, I can also look at the top. The top says -6, 12. So I click here. So now I've created this parabola, and I save it. And then if I check my answer, it's correct. All right, let's do another one. I'm going to skip down here to, I want to do this question number 4. So for this one, once again, let me write down this information. The vertex is -2, -3. And the focus is at 0, -3. And they want us to find the same information as the last problem. So a difference is the last problem, if you recall, the vertex was at 0, 0. Now the vertex is not at the origin. So once again, the way you always need to start these problems is plot the information you were given. And that will right away pretty much tell you what kind of problem you're going to have. And therefore, that will tell you which standard equation you need to use. So focus 0, -3. So x0, y -3. So that should be the focus. The vertex -2, -3. So x -2, y -3. So you can see this parabola is going to open to the right. So it's going to open to the right. The standard equation for that kind of parabola is going to be y minus k squared equals 4p x minus h. This is the standard equation for a left or right parabola. You have to memorize. You don't have to memorize the formula. The formula is here on the formula sheet. But you have to know that this one is the left and right, and this one is the up and down. That's what you have to memorize, or you have to know. So if the vertex is -2, -3, that's h, and that's k. If I plug those in, so -3 is k. So if I subtract a -3, ends up being +3. Let's go ahead and determine the p. P is always the distance between the vertex and the focus. In this case, it's 2. So I'm going to put a 2 in for p, which makes this 8. And then my h is -2. So x minus -2, x plus 2. So now the last thing I have to check, should this be a positive or negative term? And since this is going to open to the right, that ends up being positive. So this should be my equation. We'll enter that into the computer in a few minutes. Now we need to find the 2 points for the latest rectum. And for the latest rectum, we calculate 2p. Since p is 2, it's going to be 4. So what you do is, from the focus, I'm going to move up 4 and down 4. So 1, 2, 3, 4, and then 1, 2, 3, 4. So those 2 points, this is going to be 0, 1. And this is going to be 0. I'm down here at -3, and I went 4 more, so -7. And I'm going to create the graph on the computer, but that's what it would look like. So this is the information now. I'm going to now go back to the computer program, enter this information. Hopefully it's correct, and we can plot this parabola. So, equation of the parabola, I have in parentheses y plus 3 quantity squared. Y plus 3 equals 8 times, in parentheses, x plus 2. So I can check this now. And thankfully, it's correct. Now, next, it's going to ask me for the latest rectum points. And we said it's 0, 1. So 0, 1. And you put a comma in between the 2 points, and then 0, -7. Check those. That's good. So now we're going to go plot it. Now I'm going to do something here. I'm going to purposefully mess up my plot so I can show you, in case you make a mistake, how to try it again. So I'm going to choose the parabola tool, and I'm just going to choose a random vertex and a random point here. and I'm going to save it. Obviously, this is not correct. And I check it, and it says that's incorrect. So you go back. Now what you do is you need to get rid of this original graph, and there's this button right here that says clear. So you hit that, clear all objects, yes, and then it gives you the chance to start again. So now let's do it correctly. So the vertex is the first I have to choose my parabola tool again, the left and right parabola. The vertex is -2, -3. So once again, you can look at the top to make sure you're on the correct point. Sometimes it's hard to see. -2, -3. I'm going to go to one point of my latest rectum. How about 0, 1? I check at the top. Yep, that's 0, 1. So now this should be the correct parabola. And I go check it, and it is. All right, we're going to do one more quick problem. Both those first two problems, the information they gave you was the vertex and the focus. We're going to do one problem where they give you a little bit different information. This one, they give us the focus, and they give us the directrix line. The directrix is always a line, a straight line. So the focus -3, 5. And the directrix is the line y equals 3. So here the information is a little different. So let's work out this problem, and we can enter the information. So once again, you always start with graphing this information. That's going to tell you what kind of parabola you have. So if the focus is -3, 5, so x is -3, and then y is 5. So there's the focus. Now the directrix is the line y equals 3. Well, 3 is right here, so it's a there's the line y equals 3. Now what happens is, if you recall, with the directrix of the focus, the vertex is always halfway in between the directrix and the focus. So if the focus is here at -3, 5, and the directrix is y equals 3, halfway in between is going to be the vertex, and it's going to be -3, 4. Now this is going to be a parabola that opens up. So the standard equations for a parabola that opens up is going to be x minus h squared equals 4p y minus k. So if the vertex in this case is -3, 4, then I put -3 in for h, I put 4 in for k, and then my equation. Now let's go ahead and figure out the p while we're doing this. The p is the distance between the vertex and the focus, or the vertex and the directrix. Those are both p. So in this case, it looks like p is going to be 1. So this is just going to be 4. So since k is 4 right here, I believe this should be the equation of the parabola. Now I think they asked for the latest rectum points, which we get that by doing our 2p calculation, which would be 2. So from the focus, I'm going to move 2 to the right. So that point there should be -1, 5. And then 2 to the left. And that's going to be minus 5, 5. So you can see this parabola might look something like this. So let's go enter this information. So here's the equation. Here's the points for the latest rectum. Let's enter it on the computer. See if it's correct, then we can create the plot. All right, so we said the equation is x plus 3 quantity squared equals, oh, one thing I forgot to say, should this be a positive or negative? And since it's opening up, it's actually positive. So it is going to be a positive 4. Sometimes I forget that to confirm whether it should be positive or negative. So this is what I believe the equation should be. We can check it. And that's good. It's correct. Here are our latest rectum points. We have minus 1, 5, and then a comma, and then negative 5, 5. Hopefully these are correct. And now we need to plot that. So once again, I'm going to go over here. Now it's an up or down parabola. In this case, it's an up. So I have to choose the up parabola tool here or choice. And my vertex is negative 3, 4. So I'll go and do it here, but I'll go up to the top and then make sure I'm at negative 3, 4, which I am. And then one of my latest rectum points is minus 1, 5. So I'll go over to minus 1 and up to 5. It's too far. I'm looking here, look at the top, minus 1, 5. I'll save that, and hopefully this is the correct parabola. Okay, so those are some problems where you're given information and you're asked to find out the other stuff.